Most people are aware of batteries through personal devices. So you know that the more functions your little handheld device has, the more power it needs, and it has to get that from its battery. So those devices have really led to some significant advances, and they're now using that battery technology in hybrid vehicles and electric cars. But in terms of the bigger picture, a very important area for electrical storage is that a lot of renewable resources, such as wind and solar, are intermittent sources. And that's not really a good way to deliver electricity to an energy-hungry society. So storage becomes a critical issue in the success of renewable resources. The whole goal with batteries is that you want to store as many ions as possible and release as many ions as possible. So there's all sorts of new materials that are being proposed going into batteries that have really high capacities, materials like silicon. And so what happens is that lots of ions can go into the material, and in the cycle of entering and leaving, some of these new anode materials can actually sort of self-pulverize, right? They're expanding and contracting so much during the electrochemical cycle, they start to crack. Cracks lead to degradations in battery performance, which can cause the materials to fail. The other problem is sometimes if you just charge it too fast or it's starting to run too hot, a battery can explode. Most commercial batteries, of course, are designed not to do that. But as you push towards putting banks and banks of batteries and you want them to be more and more efficient, this becomes a bigger problem. So two of the things that we are working on are microencapsulated mechanisms for healing those cracks and maintaining the electrical capacity of the material. And then second, we're working on ways of shutting the battery down when it does get out of control and it gets too hot, so you prevent one from possibly exploding and then triggering a short circuit and then a bigger problem. It's been quite exciting working on small batteries that are running your handheld, or even the batteries that are in an electric car, which are pretty powerful and have a lot of energy, but now you're talking about storing and discharging on a very large scale, and that is a huge challenge for the future.